Hello everyone, my name is Avinash Reddy. I have nearly 10 years of experience into software development and training. Today we'll discuss one of the Java concepts, which is arrays and strings. Let's begin with the session. Before discussing arrays, I would like to tell you a few things before discussing arrays, because that is most important for us to know. First, let's begin with what is a variable. A variable is nothing but which can store a value inside it. If I declare a variable, suppose let's say it's x. So x can store a value inside it. Now if I give x equal to 5, so 5 is a value which is stored inside x here. So x equal to 5. So equals here is an assignment operator. 5 is an integer literal. I am storing it inside a variable x. So in Java it is always important for us to specify the data type. So x is here, it's an integer type. So I'll give here int x equal to 5. Let me show you this part, how it looks like. So I'm opening a notepad over here, I'm typing this value. So x equal to 5. So what is 5 over here? 5, it's a integer literal. 5 is a value, it's an integer literal, and equals is an assignment operator. So I'm assigning value 5 to x, so it's an assignment operator. So it's an assignment operator. Now x is a variable here, x is a variable here. So for me in Java it is required to specify the data type over here, which is int. So int x equal to 5. So that's how I declare variables in Java, declare and initialize variables in Java. So now here x is storing a value of 5. Now if I assign a value x equal to 9 in the next step, so first I am assigning x equal to 5, and then I'm assigning 9 to x. Now which value gets stored inside x? The most recent one, that is 9, gets stored, 5 gets overridden, and then 9 gets stored inside x. So by this we can say that x can store only one value at a time. When you are trying to store 9 inside x, where 5 is already present, then 9 gets stored, 5 will get overridden. So x can store only one value at a time. But what if there is a case where I want to store multiple values? Like for example, if I want to store a student marks of one subject, then I can use a single variable. But what if I want to store marks of 5 subjects for a single student? Then in that case I require a variable which can store 5 values, right? In that case I'll go for using arrays. So arrays came into picture where we can store multiple values of similar type. So variable can store only one value at a time, but whereas arrays can store multiple values at a time. So let's begin with this presentation. So we'll look into working of arrays in Java, and then we'll see strings. So first, arrays. Arrays are objects in Java. So why we are saying arrays are objects in Java? Because as we know that where all the objects are created, all the objects are created on the heap memory, right? So Java has different memories, like we have heap memory, we have stack, and we have string constant pool. So different memories we have. So arrays are objects we are seeing. It means that arrays are created on the heap memory. So when constructing an array, it also will be using a keyword called a new. So as we know, new is an instance. When we want to create an object of any class, we'll be using the instance new. For example, let's take car is a class we have. So I want to create an object for the car class. So how I'll be writing the syntax for this one? Car C equals new car. C here is a reference variable, new is an instance, and car is the class name. So car C equals new car will create a new object. So where the object gets created, car object, it is created on the heap memory. Similarly, when creating arrays also will be using new keyword followed with the data type. So every time whenever I'm using new keyword, it creates an object on the heap memory. So that's why we are creating an object of array that gets created on the heap memory. So arrays are objects in Java that store multiple values of same type. So of same type I'm saying over here because if you want to store integers, you can store only integers. If you want to store floating values, you can store only floating values. If you want to store characters, it can store only characters. So arrays are nothing but it's an object in Java which will be stored on the heap memory, and it can store multiple values of a similar type. So the drawback that we have with a variable where it can store only one value, we can that limit which we have it for a variable, we can overcome that limit by using arrays where we can store multiple values of a similar type. So arrays can hold both primitives or object references. Now arrays can store both primitives or object references. What does this mean? Like arrays can store simple primitive values. Now primitive values are nothing but it's a pure decimal numbers or non-decimal numbers or characters or strings. So they are primitives. Not strings, only characters or numbers. So I can store primitive values like for example, I want to store marks of all students. Now marks of students are nothing but they are primitive values. So those primitive values, either I can store it inside an array or else I can store object references inside an array. Means I'll create an object for car class, I'll create an object for dog class. Like car class, I can create an object by giving car C equals new car, and dog class I can create an object by giving dog D equals new dog. Now array can store C variable inside it, which is object reference. Array can also store D variable inside it, which is again object reference. So arrays can store both primitives and also object references. Now but array itself will always be an object on the heap. Because we are constructing an array by using a new keyword, as said, it will always be an object on the heap memory, even if the array holds primitive value or object reference. So arrays can hold both primitives like simple numbers or characters it can hold, or else it can hold object references. But whenever you are creating an array, the array gets created on the heap memory. So this is little basic about array. So let's dig more deep into what arrays are. So how we declare an arrays. So for the declaration of an array, we need to specify the square brackets. So when we are declaring a simple variable, we are going to give the data type followed with the variable. Similarly, when you are going to give the array declaration, you're going to provide the square brackets. So square brackets are nothing but the representation of an array. Now we can provide the square brackets either after the variable name or after the data type. But I suggest you to provide this square brackets after the data type, as we can see in the slide. And the second one we can see the declaration where the square brackets are provided after the data type. So by this way it becomes more readable. So if you are providing square brackets after the data type, it becomes more readable. So this is these are two different ways that we are going to declare an array. Now here if you look at the screen, you can find it like key is nothing but it's the name that we have given for the array, and int is the data type, and the square brackets represent array. Now this key here, a variable can hold multiple values which are of same type. Now what is that same type? It's nothing but the integer type. Now integer type, multiple values it can hold if you are going to give it this way. So this is nothing but it's a declaration of an array. Through this declaration we can say compiler that we are giving a name called key, and it's an array and of type integer. Let's move to the next one, how the array will be constructed. So let's see how the array will be constructed. So now we'll see here, it's a one-dimensional array. So we'll see here test scores is a name of an array that is given over here. So in the first step you can see there are two steps over here. The first step, the declaration is done. So the name of an array is test scores and it's of integer type, and you can see the square brackets are provided after the data type int. So it's a integer array and the name of the array is test scores. Now if you look at the second step, test scores equals new int of 4. We have given test scores equal to new int of 4. Now the second one is for the construction of an array. So at the time of construction of an array we are going to provide new keyword followed with the data type, and also we are going to provide the size of an array. So test scores equals new int of 4 will construct a new array on the heap memory with size 4, and the type of an array is integer array and the name of an array is test scores. So this is how we are going to construct an array. Let's see more about it. So memory representation. Now let's take the memory representation on the heap. Now this cloud is nothing but it's a heap, and we have constructed a new array of size 4. So you can see there are 4 boxes that are there. So 4 boxes. This box is nothing but it's an index. So 4 indices we have over here. So each index is filled with 0 by default. Means whenever you are creating any integer array, the default value that is placed inside each index is 0. So each box is nothing but each index. So we can see it is filled with 0 because it's a default value. So now every array, whenever you are constructing, it will always begin with 0 index. Now the position will be 0. So 0, 1, 2, 3. You can see that it is in an increasing order with 0, 1, 2, 3. So this way the array will be created. So as we have seen, the size of an array is 4 over here. So the indices that we can see are 0, 1, 2, 3. So if I give the size 5, then the indices will be 0, 1, 2, 3, 4. So you can see one number less than that, it will end at that position because it begins with position 0. So always and always array index position starts with 0 and ends one number less than that. So you can see that the array is of size 4 here, which is filled with values zeros. Those are the default values at the after constructing the array. So now let's see how the initialization is done, or let's see how the array initialization will be done. Before that, whenever we are creating an array, you always need to specify the size of an array. Without specifying the size of an array, it gives you a compile time error. JVM requires you to provide the size of an array. Now when you are giving over here, the car list is array which is constructed, so you can see that the size is not specified over here. So without specifying the size of an array, you cannot create an array. You cannot construct an array without specifying the size of an array. If you are trying to do so, it will give you a compile time error. So let's see the initialization part. Now int x equals new int of 5, you can see. Here we are constructing an array of size 5, right? So x is an array of size 5. So it begins with index 0, ends at index 4. So it will be consecutive 0, 1, 2, 3, 4. So these will be the indices of an array. Now I'm assigning a value 2 at index 4. Index 4 means it's the last index, right? Because it begins with 0, it ends at 4. So it's the last index. So x of 4 equal to 2. So 2 is the value. I'm assigning it 4th index of x array. And then in the next step, I'm assigning 3 value to the 5th index. Now 5th index is not present over here because it's beginning with 0, it ends at 4. So it gives us array index out of bound exception. If I'm assigning a value which is not bound to that index, means it is out of that index, then it gives me array index out of bound exception. So I can initialize a value like this. So if I want to initialize it for the 0th index, I'll give x of 0 equal to a value which can be anything, which can be any integer value. So x of 5 equal to 3 gives me array index out of bound exception because it is out of index position. So also you cannot give a negative number for the index position. See, in this example we have created array which is z. Z is an array with size 2. So int y equal to -3. So -3 is getting stored inside y. Now that y is something which I have given it for z array index position. So z of -3 is not possible because array indices will always be positive numbers. It begins with 0 and it can only be positive numbers, but it can never be a negative number. So this is not possible for you to have any array with a negative index number. So let's look at some multi-dimensional arrays. Till now what we have discussed is only single dimensional arrays. In single dimensional arrays you will be providing only one square brackets. For multi-dimensional arrays you will be providing many square brackets. So if you look at a two-dimensional array, you'll be providing two square brackets. So how we use this two-dimensional array or multi-dimensional array? See, when I have one value to be stored, I'll be using a variable. But if I have multiple values to be stored, I'll be using array. That is, if I have 5 subject marks of a student, I'll be using a single dimensional array. But what if I have 5 students and 5 subjects per student? Then in that case I'll be using two-dimensional array. So I'll be using 2 square brackets in that case, where one square brackets will represent the total number of students I have and another square brackets will represent the number of subjects I have per student. So that represents a two-dimensional array. We'll see how the construction is made over here. So how we declare a two-dimensional array is by providing 2 square brackets. So you can see here the declaration is done. My array is the name of an array and we are providing 2 square brackets after that. So and then there is a data type. So a data type which is int my array and then 2 square brackets. As we have seen for the declaration of a single dimensional array, it is the same case that we have. The most recommended way of writing this is to provide the square brackets after the data type. So int followed with the 2 square brackets followed with the name of the array, which is my array. So the second way of writing is the most recommended one. It is more readable way. So here this is a two-dimensional array. Now we are constructing a two-dimensional array. Again, for the construction of a two-dimensional array, what we require is to provide the size of an array. So my array here, we are constructing it by giving new int of 3 and 3. So it means that it's a 3 by 3 array. It will you'll have a base index of size 3. So 3 indices you will have, base 3 indices, and then each index will hold another array of size 3 here. So it's a 3 by 3 array. In this case, if I take an example, I can store 3 subjects marks for 3 students if I go with this array. So let's see the initialization part. First I have created an array. The name of an array is A, and I'm storing values 5, 6, 7 inside it. So I can also initialize the values to any array by providing the curly brackets. So inside the curly brackets I can see the values that are present over here, 5, 6, 7. So 5 is placed at 0th position of array, and 6 is placed at the first index, and 7 is placed at the second index. So 5 at 0 index, 6 at first index, and 7 at second index. So I can provide the values this way. So here the size of an array will be 3 because we are storing the 3 numbers over here. The size of an array will be 3 over here. So even this way it is possible without providing the size of an array. Directly we can initialize the values to the array. So int a equal to 5 comma 6 comma 7. So the size of an array here it will be 3. Now let's see my array of 0. Now my array of 0 can store 3 values inside it. Because it's provided with size 3, it can store 3 values inside it. So I'm giving 3 values which are 1 comma 2 comma 3. So my array of 0 is 1 comma 2 comma 3. I'm storing 3 values inside it, and my array of 1 can also store 3 values inside it, which are 3 comma 4 comma 5. So I can either give inside curly brackets which is 1 comma 2 comma 3, or I can also give it this way, which is new int of declaring the array and then provide with the values 3 comma 4 comma 5. Both will be same. Either way you can provide the values. So my array of 2 equals a. So a array is 5 comma 6 comma 7, which gets copied into my array of 2. So my array of 2 will store 5 comma 6 comma 7. So a is copied into my array of 2 here. So my array of 0 0 means I'm changing the value. First what is the value that I have for my array of 0 0? It is 1. My array of 0 1 I have 2, and my array of 0 2 I have 3. So my array of 0 0 I'm making it 3. So I'm assigning with value 3. So 1 will be lost and 3 gets stored inside it. My array of 0 1, the value which is already present is 2, and then again I am placing 2 inside it, so there is no change in this one. My array of 0 2, I have a value 3 inside it, and I am storing 1 now, so 3 will be lost and 1 gets stored inside it. So this way I am changing the values inside my array. Let's see the memory representation of my array. So if I take this cloud as a heap memory, so you can find there is a base array for this one, which is my array. So with indices 0 1 2 are the indices over here. At 0 I'm placing an array. 0 is holding entire array, which is with the values 3 2 1, and then 1 is holding, 1 index is holding, my array of 1 index is holding an entire new array which is 3 4 5, and my array of 2 is again holding with values 5 6 7. Like that we can have a base matrix, array which can hold another, each index of this can hold another new array. That is the 2-dimensional representation of my array. So if whenever I want to retrieve any values from here, so for example I want to retrieve value 7 over here, I'll be using both the index positions. So for 7 it will be my array of 2 2. Okay, my array of 2 2 will retrieve me a value 7 inside it. So now let's see what is jagged array or zigzag array. For jagged array or zigzag array, you are not going to specify the size for the second brackets. Means only when you specify the size for the first brackets, it is enough. So the base array will be created, and this and the second square brackets are not required to specify the size over here. It will be dynamic in nature. So let's see how it works. So I have created an array, a single dimensional array with values 9 8 5. So the name of the array is A here, and it is storing values 9 8 5 inside it. And I have another array which is 2-dimensional array, which is my array. Now it is created with base 3 and my array of 0. So I'm placing 6 comma 7 inside my array of 0, and I'm copying a array at my array of 1. Now at 0 I have only 2 values, which are 6 7, and at my array of 1 I have 3 values which are getting copied. Those are 9 8 5. So I can have, if I'm leaving the second square brackets, I can place as many values as I want. Like the max values, I can place it over here, as many values as I can. So that will be dynamic in nature. That is called as a jagged array or a zigzag array. Let's see the memory representation of this one. So I've created a my array of size 3. So we can see 0, 1, 2 will be the base indices, and 0 is holding 6 and 7, and 1 is holding 9, 8, 5, and 2 is null because there is no single dimensional array that is created, so 2 is not holding anything, it is stored with null. So for declaring, constructing and initialize, we'll see you can also, as we have discussed, you can also initialize the values to the array without providing the size directly through the curly brackets which we have given over here, 3, 6, value some x value and then 8. So we can also x is 9 over here, so 3, 6, 9, 8. So we can also give initialize the values by providing this curly brackets. And also we can see the same thing for the two-dimensional array. For the two-dimensional array, here we can see scores is a two-dimensional array, so we have given 2 square brackets after the data type, and then when initializing we are providing with square brackets, which initializing we are providing with curly brackets, that is 5, 2, 4, 7 is an array here. So 5, 2, 4, 7 is an array. And then we have another array which is 9, 2, and then we have another array which is 3, 4. So we have 3 different arrays over here. 5, 2, 4, 7 is one array, and 9, 2 is another array, and 3, 4 is another array. So all the 3 arrays we are going to place inside the curly brackets, so it becomes a two-dimensional array. Now let's see something about strings. Now strings are nothing but it's a sequence of characters. So we have 3 different Java classes for handling strings. Those are nothing but java.lang.String or java.lang.StringBuffer, java.lang.String builder. There are certain differences between these 3 different classes, and more or less they are same. They are used for handling strings. And a string is nothing but it's a series of characters. Series of characters in this sense, I can store any characters, like I can store my name or I can store hello string, like that. So strings are nothing but it's a sequence of characters, and strings in Java are not merely a sequence of characters, they are also immutable objects. So here when I am referring the keyword immutable in the sense, the word immutable means it is not changeable or not modifiable. It means that whenever I am creating a string object, I cannot modify the object. If I am trying to do so, what happens is it will create another object. Let's take an example, like if I created a string object with series of characters, that is hello. So I want to remove the character O, or I want to replace the character O, which is the last character of the string. So if I try to do that, what happens is it will create a new object. So immutable, string is immutable, means the existing object cannot be modified. Whenever you are modifying something inside the string, it creates a new object, that is immutability. So strings are immutable in Java. So how we can create a string? We can create a string by 2 ways. One is either providing a new keyword, or the second way is by giving a string literal. String literal in the sense we are going to simply assign the value by using an assignment operator. So J2EE is string literal, we call it. So we are assigning J2EE to S3. S3 is nothing but it's a string variable over here. So this is a string literal, and the first way is by using a new keyword, which is string S1 equals new string, or string S2 equals new string of Java. So Java is nothing but it's an object which is created, and it is storing it inside S2. So these two are the different ways where we are going to create the string. There is a we'll see what the difference that we find in creating both the ways. So the first way of creating the strings, will be stored inside heap memory. As we said, whenever we are using new keyword for creating any object, it gets stored inside heap memory. And the second way of creating the string, which is by using a string literal, it will be stored in the string constant pool. So we'll see more in depth of it. So so let's understand about string immutability, understanding the string immutability. So first is I've created string s1 equals new string of Java. So the first object which is created is Java object. So it is placed on the heap memory. So s1 is referring to the Java. And the second object that is created is j2ee. So j2ee is the string which is created and it is also placed in heap memory. So s2 is pointing to heap memory. So I'm performing a concatenation of s2 and s1. So s1 dot concat of s2. Now what is concat over here? Concatenation is nothing but appending two strings. So concatenation is a method that is an inbuilt method which is already available in Java strings class. So I can use that for concatenating two strings, appending two strings. So s1 dot concat of s2. If I perform this one, s1 dot concat of s2, so s2 what I have is j2ee, so it gets appended to s1, which is Java. So Java and j2ee, so it becomes, the final string will become Java j2ee. Now if you notice over here in the heap memory, in the second diagram, we can see that there are two objects, total three objects we have. The first two objects are Java j2ee, and then when you are modifying the s2, we are modifying the s2 by giving s1 dot concat of s2, and we are storing this inside s2 itself. So s2, which is initially pointing to j2ee in the first diagram, will now point to Java j2ee, the new object which is created. The new object which is created is Java j2ee. So s2 points to the new object which is Java j2ee. So what happens to the object which is already existing, which is j2ee? So it will lose its reference. It will be present in the heap memory till the time garbage collection happens. Till the time garbage collection happens, it will be there in the heap memory, but it will be losing its reference. So the new s2 will be pointing to the new object which is Java j2ee. So this is the immutability, means here I am trying to modify j2ee string, but it is creating a new object which is Java j2ee, and the old object is still there on the heap memory, but it will be garbage collected because it's lost. It lost its reference. Now let's understand something about string constant pool and heap memory. String constant pool is nothing but it's a memory inside heap memory itself. So heap will hold all the objects, whereas string constant pool will hold objects of string literals. So whenever I create an object by giving a string literal, then the object gets stored inside string constant pool. Whenever I am using a new keyword, the object gets stored inside the heap memory. If I'm not using the new keyword, I'm simply giving string literal, it gets stored inside the string constant pool. Now string constant pool is nothing but it's a memory which is present in the heap itself. String constant pool is present in the heap itself. So the first string here which is created is string s1 equals Microsoft. So Microsoft is a string literal which is stored. Microsoft is a string literal which is stored in the string constant pool, and string s2 equal to IBM. So IBM is also a string literal which gets stored in the string constant pool. And then string s3 equals Microsoft. Now we can see that s1 and s3 both have Microsoft and both are string literals. So it will not create any additional objects because Microsoft object is already present in the string constant pool. So s1 and s3 point to the same object. Now string s4 equals new string of Microsoft. Because we have given new string here, the object gets created in the heap memory. So the Microsoft objects get created in the heap memory. And then we have string s5 equals s4. So s4 is copied into s5. So s4 is nothing but it's a Microsoft object which is created in the heap memory. So that gets copied into s5. So we'll see the representation over here. So S1 is a string literal Microsoft, so it is created in the string constant pool, and S2 is a string literal again. It's an object which is created in the string constant pool IBM, and then S3 points to the same Microsoft which is already created in the string constant pool, and S4 is a Microsoft object which is created in the heap memory, and S4 is copied into S5, so S4 and S5 are both pointing to Microsoft object in the heap memory. So that's how string literals are created in the string constant pool memory, and then string objects with new keyword are created in the heap memory. So string constant pool is nothing but it's a special memory set aside by JVM in the heap memory itself to make Java more efficient, and we'll see how understanding the different ways to create a string object. So the first one here you can see S1 is a string literal, so it's created in the string constant pool, and S2 is created in the created in the heap memory. So Reddy is the object which is created in the heap memory, and S3 is Noida, which is object which will be created in the heap memory. So it will create another object which is S3 in the heap memory. So let's see how plus operator works. Plus operator is used for concatenation. As we have seen in the previous slides, that concat is the method that we are using from the string class. We have a concat method. Plus is also used for concatenation, appending two strings. When we are using plus, it is present in the java.lang.Object, which is a superclass of all classes in the Java. So plus is a concatenation which is present in the object class, which is a superclass of all the classes. So int a equal to 6. Now 6 is a value which is stored inside a. It's a primitive value, so it will not be stored in both of these memories. It is stored outside of these two memories. So I have represented over here a, which is holding a value 6, and char c equals a. So a is stored inside c variable. A is stored inside C variable. Again, it's a primitive value which is stored outside of these two memories. And the string S1 equal to is. So is getting stored inside string pool, because it's a string literal, it is getting stored inside string literal. And the string S2 equals new string of whole number. So whole number is an object which is created, which gets stored inside heap memory. So S2 is a whole number which is getting created in the heap memory. So system.out.println a plus S1 plus C plus S2. So plus is a concatenation. So concatenation of strings over here. So a is nothing but 6, S1 is nothing but is, C is nothing but a, S2 is nothing but whole number. So what happens here? It is 6 is a whole number. So it will create a new object which is 6 is a whole number. So before printing this statement, it will create a new object which is 6 is a whole number. Now where the object will be stored, the object will obviously be stored in the string constant pool. Because we are using a plus operator over here, the object gets stored in the string constant pool. So we can see that 6 is a whole number is an object which is created in the string constant pool before printing it onto the console. Now these are few methods that are present inside the string class. Char add is a method. We have to provide the index position. So whenever you are giving any index position, it returns to that character. Now hello, let's take an example like hello is a string. So if I give the index position 2, so char add of 2, so it will return me with the character at the second index, which is L. So it returns with the L. And the second method that we have is concat. Concat, we have seen the example also, that is for appending two strings. And the next method we have is equal ignore case. So we have equals and equals ignore case, two different methods. Equals is used to check whether the both strings are the same or not. So if I am giving two strings, string s1 equals hello, string s2 equals hello, so it will return true if equals will return true if both both the strings are hello and with the same case characters. So if I want to ignore the case, then in that case I'll be using equals ignore case. Means the first string can be hello with capital H, and the second string can be all small letters, hello with all small letters. Then in that case equals returns false, and equals ignore case will return true, because equals ignore case will not look into the case, character case. So that is equals ignore case. And next method we have is length method. Now length method will return the number of characters that are present inside the string. So if hello is a string, then it will return with the 5, because 5 will be the total number of characters inside hello. So when using the length method in terms of array or in terms of a string, we should not get confused over here, because length method, if it's a method, it will be present with the parenthesis. So length method will have the parenthesis, and with parenthesis length will be using it for the string. So here we have created a string which is string s equals winter. So it's a string literal, string object is winter here. So we need to provide a length method over here to get the length of this string, which is s dot length. If I'm simply giving s dot length without parenthesis, then it's invalid. I have to provide parenthesis after length. And here we have created a character array which is char c equals new char of summer. So we character array is nothing but it can store single character. So like single characters, multiple single characters. So we have created a character array, and to find out the length of a character array, we are going to give length without providing the parenthesis. Now the length there, it is a variable. So the difference that we have is length method and the length variable. If you are giving with parenthesis, it becomes a method. If you are not giving with parenthesis, it becomes a length variable. So length variable is something which we have to give it for the to know the size of the character array. So c dot length. C dot length here, it becomes invalid if you are giving parenthesis. If you are not giving parenthesis, then it is a valid one. So without giving parenthesis means it is the variable. Now let's see how the shallow and deep comparison that works. First I have created a string s1 equals star. So s1 is an object which is created in the string constant pool, and s2 equals star means s1 and s2 both are same, so both will point to the same object. S1 and S2 point to the same object which is created in the string constant pool, and S3 equals new string of star. Now the new string of star is created on the heap memory. So S3 is a star, S3 points to the star which is created on the heap memory. Now when we are looking into S1, when we are comparing with S2, which is object reference comparison, so if I have two equal sign, it's object reference comparison where it will check for whether they both are pointing to the same object or not, whether they are holding same reference object, same reference or not. So S1 and S2, are they holding the same reference? Yes, S1 and S2 are holding the same reference because and S1 and S2 are pointing to the same object, so it will return true. And the second system.out.println will return as S1 dot equals S2. This will also return as true because S1 dot equals. Now equals method here will compare the values inside the strings. They both have the same value or not. So S1 is having a value which is star, and S2 is also having a value which is star. So they both are having the same value, so it will return true. And then the third system.out.println, we have S1 equals, which is object reference comparison. S1 and S3, are they pointing to the same object? No, S1 is pointing to the star object which is created in the string constant pool, and S3 is pointing to the star object which is created in the heap memory. So they both are not pointing to the same object, so it will return false. They both don't have the same object reference, so it will return as false. S2 dot equals S3. Now S2 dot equals S3 will return as here true, because S2 is having a value which is star, and S3 is also having a value which is star. So both values are same, so it will return as true. So the difference that we find it in using two equals sign, which is object reference, is the equals method which is present in the object class, and if you are using equals method, that is present in the string class, and if you are using object reference comparison, that is present in the object class. So we can see the memory representation of this one. S2 and S1 are pointing to the same object which is star created on the string constant pool, and S3 is a star object which is created in the heap memory. Okay, now let's see what is a StringBuffer. As we have discussed, string is a class which is immutable, means we cannot modify the string. StringBuffer and StringBuilder are two different classes which will be using where the strings can be modified within the same object. So they are mutable, means you can modify the same object, existing object, you can modify any characters inside it. So first, if it's in the case of a string s equals keyboard, s dot concat of mouse. So here in this case, it will create a new object. As we have discussed, string is immutable, so it will create another object which is keyboard mouse. So s will be pointing to the new object which is keyboard mouse. Similarly with the tomcat also, string s equal to tom, s dot concat of cat, we are storing it inside s variable, so it becomes tomcat. Tomcat is a new object which is created, and s starts pointing to the new object which is tomcat. So if it is a string buffer, first string buffer sb equals micro, and then sb dot append. So in here we have in string buffer append method for concatenating two strings. So sb dot append of soft. So the new object will become Microsoft. So it will not create another object here, it will modify the existing object which is already created, that is, it becomes Microsoft. So if you print SB, it will print Microsoft. So these are the methods, few methods inside the string buffer, which is append method. We can use it in different ways with different parameters, method arguments. So sb dot append of 5 greater than 6 equals, if I give 5 greater than 6 equals inside the double quotes, then it will be taken as a string. So 5, if I simply give 5 greater than 6, then it will evaluate the value. So StringBuffer also has this capability to evaluate the expressions. So 5 greater than 6 if I am providing over here, so it will return false, because 5 is not greater than 6, it will return false. So it will evaluate the expression and show us the result in case of StringBuffer. I have other methods, like insert is another method I have for StringBuffer. Insert method is used when I want to insert a particular character at a particular position. So I can see the first StringBuffer object is created, StringBuffer SB equals new StringBuffer of A, B, C, D, E, F, G. So I have a new object which is A, B, C, D, E, F, G, and I am trying to insert a space at second position. So SB dot insert of 2 comma space, I can see. So space is inserted at second position. So system.out.println, if I give SB, so it is taking a space at second position. So by using an insert method, I can insert the character at a particular position. Now I also have a reverse method which will reverse the string. So if I give string buffer sb equals new string buffer of pool, sb dot reverse if I give, so it will reverse the string. Now it will print as loop, pool becomes loop. And the toString is method that we are going to use it whenever we want to print something, like because in StringBuffer it will be stored in the form of object. So object, if you are printing it directly, then we cannot read, it is not in the readable format. So to convert it into readable format, we'll be using toString method. So now let's see this one, StringBuffer sb1 equals new StringBuffer of Microsoft. So new Microsoft object is created, and then StringBuffer sb2 equals new StringBuffer of Microsoft. So in this case, whether sb1 and sb2 point to the same object, or else it will create two different objects. Yes, it will create two different objects because why it will create two different objects? Because StringBuffer is modifiable, it is mutable. So if I make any changes to sb1 object Microsoft, then it should not affect another object which is sb2. So it will create two different objects because it's mutable. It will create two different objects. So system.out.println sb1 equals sb2 means object reference. I am using it over here. Object reference comparison. So sb1 and sb2, are they both have the same reference or not? Are they both pointing to the same object or not? In this case, it is false. They both are different objects. They both are not pointing to the same object, so it will return as false. And then we have system.out.println sb1 equals sb2. So equals method, I am using it over here. So sb1 equals sb2. What is equals method? Equals method will see whether the both values are same or not. So sb1 is having Microsoft and sb2 is also having Microsoft. So they both are same. But then it returns false. Why it returns false is because equals method is not present in StringBuffer. So it will refer to the parent equals method. Parent equals method is nothing but, again, it's a object reference comparison, so which is present in the java.lang.object. So it will return false in this case. So that's about strings concept. Like we have seen StringBuffer, strings and StringBuffer. Thank you very much.